Hello, everybody. Welcome back. Today we're looking at 5.3. We're looking at standard deviation. And what is standard deviation? Standard deviation is the measure of dispersion. It describes the spread of the data. So how the data is spread out. And we're going to learn more about that in the next few sections to get an understanding of what that represents. The symbol for standard deviation is the Greek letter sigma, right here. Okay. And to the formula to calculate standard deviation looks a little complicated. I'm going to show you some ways to do it with technology as well. So sigma is equal to the square root of the sum of any of your x value minus your mean of those x values squared, all divided by the number of total in the population. So we look at standard deviation of population. And there's also what's called sample, but we'll talk about that if that comes about. But that's probably for a further stats course. But right now we're just looking at population data. So sigma, remember, is the uppercase sigma summation sign. So it's the sum of. X is each piece of data. X with a line over it, that's read as X bar, right? We learned that in some of the last sections. That represents the mean of the data, and N is the number of data values total. So let's look at the example I have here. It says, use the following data to determine the standard deviation. It has 5 players and their field goal percentage in the last 10 basketball games. So what we're going to do is we're going to pick one of them. I just picked random. We have Page's field goal percentage. We'll do deviation, square of the deviation, what that looks like, and how we calculate the standard deviation. Okay? So I'm going to write down the piece of information from Page's field goal percentage. So 34, 34, 35, 33, 35, 33, 34, 33, 35, 34. Pretty consistent, as you can see. All right. And the average, so to get the average of these, obviously we did that in one of our previous sections. So here's how we do that. So to get the sum of the x values, we add all these values up. There's 10 of them, so we're dividing by 10 to get the average. We add them up, it's 339, so I just added up these 10 pieces of data, and that gives us 33.9 for our mean. So we can enter 33.9 here. Okay? And that is the mean. So the deviation is your x value minus the mean. So all we do is, I'll do one sample calculation and then I'll just put the rest in. So it would be 34 minus 33.9, which is equal to 0.1. Okay, 0.1. And we do that for all these, so that would be 1.1. That would be negative 0.9. 35 is 1.1 again. 33 is negative 0.9. So they would be the same. And 34 was 0.1. So all I'm doing is I'm taking the field goal percentage, Page's field goal percentage, and subtracting the mean. And that is the deviations. And the square of the deviation, I'm just squaring this number. So I'm literally taking 0.1 and I'm squaring it. And squaring it. And I'm going to put it in brackets. You don't need it for the positive values, but you definitely need it for the negative values. Right? And that will equal 0.01. Right? 0.01 when we square that. So the square of 1.1, again, I'm just going to do these on a calculator, but I'm showing the sample calculation in the first line. The rest I'm just doing. So 1.1 squared is 1.21. Okay. Negative 0.9 squared would be positive 0.81. 1.21, we did that one already. 0.81. 0.01, 0.81, 1.21, 0.01, and 0.81. So these are the square of the deviations. Determine the mean of the square of the deviation. So we take the mean of here. So what we're going to do is the same thing. We're going to add these all up. All right. Then we get the mean here. And when we add them all up, that gives us 6.9 divided by 10, which would be 0.69. So that's the answer here. Determine the mean of the, right there. So I've done that. 0.69, and then I take the square root of that. So square root 0.69, and that is the standard deviation. A lot of tedious work. You would be correct in saying that. So when we take the square root, we're going to get square root 0.69. We get 0.830662338, and so on. Right? And that value that we obtain right here is the standard deviation, okay, of the population standard deviation, and that's what we're going to be solving. I'm going to show you how to do that on your graphing technology, and I'm also going to show you how to do that on Desmos. So it's two great programs. So I'm going to open up our graphing calculator, okay. I'm going to hit stat again like we did last time, hit edit. I got a lot of numbers in the list, so I don't want to empty these lists because I want to show those. So you can go up to 6 lists, so we're good here. So I put pages data in list 6, 34, 35, 33, 35, 33, 34, 33, 35, 34, 33. So there's all the data. So once you have the data in list 6, and there's 10 of them, you list 6, 10 pieces of data, and the last one 33, hit stat. Go right over to calc, one various stats, hit enter. It's list 6 because I already had it, so whatever list you're putting the data in, you'll have to put there. Just go down until you get to calculate and hit enter. So you notice it already took the mean for us. That was that first column that we have right here. It did that for us. It should show the sum of those x values. And we're interested right here in sigma x, right? So this is the standard deviation, and this is the exact number that we have here, 0.83066233863. That's allows us. So a lot quicker when we use the graphing technology. I'll also show you how to do that on the graphing calculator. So, on Desmos program. So we hit plus, put in a table. And you can add those data pieces in again, 34, 35, 33, 35, 33, 34, 33, 35, oh, that should be 35, sorry, 34, 33. Just go over them again, double check. I do have all 5 pieces. We'll double check that. So now, if you look at the bottom of your screen, you have a little keyboard, click up, go to functions, stats, and you look down, it's standard deviation P. There's standard deviation, but standard deviation population is what we're interested in. And it'll automatically open up the brackets, and we want the X1 data, right? That X1 list that we created. And there it is, that exact number again, 0.8306623. That's the standard deviation. So a lot easier to calculate standard deviation using Desmos or the graphing technology instead of doing it by hand. Okay? So you can use whatever you're comfortable with. Again, depending on what size data you have, it's you can do it pretty quick by hand as well. But that's how you calculate it. And again, at least this could show you that you definitely have it calculated correctly. Okay, so that's going to be it for this video on standard deviation. I want to start the next video because we're not going to have enough time. So in the next video, we're going to look at example 2. We're going to look at test scores and how to find the mean. So thanks everybody for watching, and I hope the videos are helping, and we'll talk again soon.